Okay, in this presentation we are going to look at a combinations worked example. So combinations and permutations are part of what is generally called counting problems, and that is generally part of Introduction to Probability courses, okay, or parts of those courses. Let's assume that you have four shirts. One is red, one is green, one is brown, and one is black. Actually, green, red, brown, black. We have two jackets, blue and black, and two pairs of trousers, brown and black. So, how many outfits do you have altogether? What if the shirt must be red? What if the shirt must be black or green? What if the shirt must be green and the jacket must be blue? What if no item is to be black? And what if at least one item is to be black? And what if the shirt and jacket can be the same color, but the trousers must be a different color? These are sort of straightforward enough, really, so we'll just work through them fairly quickly. Okay, so just as a remark, this is not a permutation problem because you're not concerned with the order of the elements, and this is a combination problem because the order of the elements does not matter. We're simply selecting combinations of shirt, jackets, and trousers to form outfits. So just actually remember that that's really one of the exercises. What is the difference between permutations and combinations, and how to recognize which is which? Okay, so exercise A, how many outfits do you have altogether? So the total number of outfits, multiply the number of options for shirts, jackets, and trousers. We have 4 shirt options, we have 2 jacket options, and we have 2 trouser options. So we have 16 possible outfits that we can make out of our clothes. So there are 16 possible outfits. Okay, so that's exercise A. Exercise B, what if the shirt must be red? Okay, so if the shirt must be red, essentially we've one fixed option for the shirt, the red shirt. Okay, we still have 2 options for the jacket and 2 options for the trousers. So one shirt times 2 jackets times 2 trousers. Essentially we have 4 possible combinations. Okay, so there are 4 possible outfits that we can have if the shirt must be red. So moving on. So again, this is similar to the last one. What if the shirt must be green or black? Okay, so we have a green or black shirt, so we have 2 possible options for the shirt. We still have 2 options for the jacket and 2 options for the trousers. So we have 2 shirts times 2 jackets times 2 trousers. We have 8 possible options. So there are 8 possible outfits that if the shirt must be green or black. So we're working through this quite nicely. What if the shirt must be green and the jacket must be blue? Essentially, we have 2 constraints now. So if the shirt must be green and the jacket must be blue, we have 1 fixed option for each, the shirt and the jacket. So essentially, it's a matter of picking which one of the 2 trousers we are going to have with it. Okay, so essentially 1 shirt times 1 jacket, and we have 2 options for the trousers. So we have 2 possible combination of clothes, 2 outfits altogether. So there are 2 possible outfits if the shirt must be green or black, and if the shirt must be green and the jacket must be blue. Now, what if no item is to be black? Okay, so just recall we have 3 shirt options, but one of them is black, so we can't use that. 2 jacket options, one of them is black, so we can't use that one. And 1 trouser option because one of them is black and we can't use that one. So we have 3 times 1 times 1. So we have 3 outfits altogether. So this is where we start to bring in this idea of using, the complement of something. Sort of looking at the opposite of what we're asked and then just trying to see the difference. Okay? And that's an important way of thinking about things when you deal with probability problems. Okay? So that's a skill we're looking to develop here. Okay? So anyway, 3 possible options, 3 possible outfits if no item is to be black. Okay, just look at what we can use, and then work from there. Okay. Now, what if at least one item must be black? Okay, so this is an extension of what I've just said previously. Okay, and it's just looking at the idea of a complement, which is very useful sort of way of thinking about these problems. And this just actually takes the next step. So to find the total number of outfits where at least one item is black, we subtract the total number of outfits where there's no black items, which is what we just done in previous the exercise E. We found that there were 3 outfits where we three possible combinations where there was no black clothes involved. We have 16 options altogether, 16 total outfits. Okay, that means that of the 16 total possible options that we have for outfits, 3 of them have no black at all. Okay, so that means the remaining 13 must have some black clothes in there somewhere. Black trousers, black shirt, black jacket. There must be some blackwear there somewhere. Okay, so that's the idea of bringing in this idea of a complement. So there's 13 possible outfits there, where at least one item of clothing must be black. And finally, what if the shirt and the jacket can be the same color, but the trousers must be a different color? Okay, now we have to put this all together. Okay, so this actually requires a little bit of thinking. Now, a lot of the first questions, the first set of questions, are easy enough, but this actually requires us to sort of sit down and do a bit of thinking. So what we have here is all the possible options. Okay, so we have 3 ways we can have a shirt and the jacket the same color. The shirt and jacket both black, shirt and jacket both green, shirt and jacket both brown. Okay, but essentially, if we have a black jacket, okay, that means we have to have a brown trousers. Can't have the brown the same color. So essentially, it's just looking through all the options that we had at the start. Okay, and just starting off with the shirt and the jacket, where can we build up where they have the same color? Okay, and what works in terms of having a different color for the trousers? Okay, so actually, it turns out there are 3 shirt options. And matching jacket options, but the trousers must be different from the top combination. Okay, so that's just actually the ones we can't use. So calculate the total number of outfits, and essentially we end up with 3 options. That's it, essentially. So the 3 possible options: if the shirt and jacket can be the same color, but the trousers must be a different color. So that's it, really. You just have to sort of look at it, think it through, just take your time with it, write out all the options there, because that's probably the last one. There is probably where you have to sort of do a bit of thinking. The previous one's fairly straightforward, really. Okay, we'll leave it there.